I'm Anil Kumar. Welcome to my series on calculus. We're sharing with you questions from previous test papers. In this video, we'll discuss derivatives of logarithms and exponential functions. Here is question number 6 from a test paper of my student. Question number 6 here is, the population of foxes in a provincial park has been modeled using the following equation, where t is time in years. P of t equals to 50 ln t plus 1 divided by t plus 1 plus 40. Part A. Write the initial population. B. Determine the initial rate of change of population of foxes. And C is, determine the maximum population of the foxes on the interval 0 to 4. Take ln 5 as equal to approximately 1.6 and E as approximately 2.72. Now this is part of a test paper where calculators are not allowed, right? So they have given you approximate values to do the calculation. Part A is write the initial population. So initial will mean t equals to 0. So we'll substitute 0 here and then find the answer. So we get 50 ln 0 plus 1, which is ln 1, plus we have 0 plus 1 plus 40. Now ln 1 is 0, so we get this whole thing as 0. So we are left with just 40, right? So the answer is 40, and we're talking about foxes. Part B. Determine the initial rate of change of population. That means we need to find the derivative. So derivative of this function is apply the quotient rule. So we have t plus 1 whole square. Derivative of this is 50 over t plus 1 times t plus 1 and minus derivative of t plus 1 is 1, so we get 50 ln t plus 1 plus 0 because 40 is a constant. So that gives us the value of derivative as equal to, this cancels, we get 50 minus 50 ln t plus 1 over t plus 1 whole square. Part B is determine the initial rate of change of population. That means we need to find the rate of change when t is 0. Substituting 0 here, we get 50 minus 50 times ln 0 plus 1 over 1, right? So that is ln 1 is 0, so we get this as 50. So it is foxes per year. Now, part C is determine the maximum population of foxes on the interval 0 to 4. So that means we need to find a critical number, right? So let's find a critical number here. That is, we're looking for the derivative to be equal to 0. Now derivative is 0 when the numerator is 0, correct? So let's equate 50 minus 50 ln t plus 1 equals to 0. So that means we have, we can take 50 on this side. So we have 50 equals to 50 ln t plus 1 equals to 0. And that means 1 equals to ln t plus 1. Now let's solve this equation to find the value of t. So we get e to the power of 1, which is e itself, equals to t plus 1, or we can say e minus 1 is t. So t equals to e minus 1 is a critical number, right? So that's a critical number. Now we are going to find the value of this population at p of 0, which we know, at e minus 1. Let's figure this out. So what is the population when t is e minus 1? Substitute here. We get 50 ln t is e minus 1 plus 1 over e minus 1 plus 1 plus 40. Now this is equal to, we have 50, that is ln e, right? So, which is just 1. So we have 50 over e plus 40. So that becomes the population. Now at 0 we know it is 40. Let's figure out what is at 4. So P of 4 will be equal to, substitute 4 here, 50 ln 4 plus 1 is 5 over 5 plus 40. That is 50 times ln 5 is 1.6 over 5 plus 40. So that is 10, so it is 16, so we get 56. Right. Let's calculate, we know P of, we already know P of 0 is 40, correct, which is much lower. So one of these two values, let's calculate this, 50 divided by E. E is 2.72, right? So let's divide this and then figure this out. So even, okay, let me do long division here. So we are going to divide 50 by 2.72, let's say 272, and let me add 2 zeros here, okay. So it could be, if I multiply by 2 times, it becomes more than 500, so 1 time. 1 time 272, and what we get here is 8, 2, and that is 1, and this is 0. So, sorry, 2. When you borrow 4, 2, right? 2280. So that's a big number. We can now multiply by 9. 9 times 7, 63. 18 and 6 is more than 22. So it'll go 8 times. So 8 times 2 is 16. 8 times 7, 56, 57. 5, 8 times 2, 16, 51. So that goes. So we get 18 here, right? So we can write this number, which is 18 plus 40, which is 58. So it is higher, right? So now we can determine the maximum population in this interval. So answer is, maximum is 58 foxes. Is that clear to you? So that is how you can actually solve this question. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.